All right, we are going to be talking about software development tools, and this will be somewhat Renesas-centric. So without further ado, let's go forward. We're going to relearn about the compilation process. I believe I've already covered this twice already. 3 times is a charm. Debugging tools, Hue, and then various and assorted other files associated with our tools that we have. So if you remember, I've showed this before, that being the tools that our integrated development environment will use. I should ask a question. How many of you have already started to use the Renesas Hue tool? All right, a few of you. I do recommend very strongly you work on it in earnest this weekend so that you can ask questions of Sam and myself when we get back from the weekend. So the 3 tools, as I've mentioned before, preprocessor, compiler, and linker. I think I've gone into this in quite a bit of detail, but the important thing to note is preprocessor. The input is C source code. The output is source code that has been preprocessed with things like macros are evaluated, and if they replace something inside of your code, then that will be done already. So then the compiler takes that output from the preprocessor, and it will create a relocatable object file. Relocatable means that it could be anywhere in memory. And it's at the linker stage where you take that object code and identify exactly what memory location it is going to go in the entire large memory map that is available for flash in your Renesas microcontroller, or for that matter, for any microcontroller. It's the same process. And the output will be the executable code in machine language that in most cases will have a format that can be downloaded to your target. Downloaded to your target means that it has some additional information that says, all right, now start loading this at this memory location. And thereafter, byte by byte, that information will be available. Now, in your tools, in Hue, I'll talk about this later, but there are certain buttons that you could press to say, okay, now download to my target. And I want to talk a little bit later about how that works, different things you have to do to allow the target to accept your code. So the compiler is compilers for embedded systems are different than what you would expect for regular PCs, in that you often have a lot of optimization for code space, or you could do it for execution time, as opposed to your typical compilers for PCs that assume that there is a lot of extra memory available. And you're going to see that embedded systems typically will run at a slower rate. What is the processor clock speed for our Renesas? That's the 12 megahertz is the input clock for the crystal for into the board. But what does the actual? We have it all over the place.
100 megahertz.
All right, it's the capability of the processor itself taking that input clock signal and actually multiplying it, and basically getting a faster clock out of that 12 megahertz. Or in the maximum would be 100 megahertz for the clock speed for your processor. So that would require a 12.5 megahertz crystal. So with the board that you have, it actually, the clock itself for the processor runs at 96 megahertz. That would be a really good test question or quiz question. I have discussed this earlier. When you have a compiler package, You, of course, have the C, C++ compiler. You have an assembler because you may have assembly code that you need to be translated into object code. You have a linker. You have a standard library generator. In other words, the ability to create and use libraries of commonly used utilities is probably the best way to put it. Utilities, and probably one of the most important things is a simulator debugger. In other words, I don't know, I should ask this. How many of you have actually used a step-by-step debugger in code before? All right, so you pretty much, most everybody here knows how to set a breakpoint, and then step by step as you hit a key, set it up such that it goes to the next instruction, then the next instruction. That way you can interrogate the different variables, right? You've all done that? Who has not done that? All right, one person, two people, three people. All right, hopefully if you raised your hand, did you see your lab partner to see if they raised their hand too? If your lab partner didn't raise your hand, you're in good shape. They can actually show you some demos. If you and your lab partner raised your hand, then you'll need to see myself or Sam or maybe one of your classmates for a demo. And we also have all of this pulled together in what we call an integrated development environment. You have already experienced the Code Composer Studio that was available from Texas Instruments, and this one is going to be HUE, High Performance Embedded Workshop, which, by the way, is also has been discontinued from Renesas. So I actually need to go in and work on updating the book so that it represents the new tool that they have, which I think is E² Studio. So we have, often in the world of debugging, you have a couple of tools. One is a debugger, which allows to control the program's execution, and as I said before, step through it, pause, just keep on going until you reach a breakpoint or whatever. And you also have a monitor, which allows other types of investigation and signals. Now, one thing that our board has, which is rather interesting, and I am not sure if I mentioned this before, but if we look at what our processor or our board really has, we have this RX63N board, and I think I mentioned this. Under the LCD is another RX63N processor, and your main RX63N processor is right here. And I believe the USB port and chip is right here, right? So when you have your PC, laptop, whatever you're talking about over here, and you're connected via USB, you really are only connected to this RX63N processor. I call it number 2. You're actually writing code that will go here. So this is what we're going to call the target. But the way our board works is they make it very easy for you to develop applications and debug these applications without the use of extensive interrogation tools like what we call a ROM monitor or an emulator, or for that matter a JTAG device. If people familiar with what JTAG is? Who is not familiar with what JTAG is? All right, enough of you that I'll cover it. in some situations, you can have some sort of header, and of course here's your microcontroller right here, and you have direct connections, and usually when you have your PC over here, and you have some way of getting signals onto this JTAG header. Sometimes there's another device that sits in between. For example, I have an Atmel processor that it's a small box, and you use it to hook on like this. But the whole idea is that inside here is memory, specifically ROM, flash-based memory. You also have RAM, and you also have registers. And the goal of a JTAG is to provide a clock such that all the data can be clocked out. Data meaning the contents of the registers of RAM and ROM. And that this clock will allow you to actually chain all of these devices such that the information can be clocked out, and actually you can clock other stuff in, like the program itself. And this is a little bit more interesting to set up. I have actually used some that are as simple as, for the MSP430, as simple as a small cable with some smarts in a, remember these, a parallel port on PCs, and it costs $12, $15 that allow you to clock information. And a lot of the work, by the way, is done inside the PC. In other words, the smarts on how to clock stuff, and then once you get the data clocked into the PC, you use it, you set up your debugging environment. And that's one way to do it. And another way, which they do it here, is the USB connected to this processor over here is equivalent to our JTAG. In other words, that processor over here is running a special program that you never write. You can download a new version of it, but you will never write that code for that processor. And it will allow communications between this extra processor via the tools. And so the instructions of let's run this processor step by step by step is actually controlled by this processor. It only allows that one to run step by step by step. And it's also grabbing the information about what the registers, the contents of registers, the contents of RAM, and passing that back to the PC, which has on its screen all of the wonderful things that says this is the contents of RAM, and allows you to stop and go. Now, I've worked with some other types of debugging environments where if this is where your processor is to go, you actually plug a big, huge piece of equipment where the processor would go, and then it comes out with hundreds of wires, and then this could be attached to a PC. And this is more of an emulator where you can emulate what the processor itself is doing on your board, and you can control everything in the board. It runs at about the same speed that the processor would run, but you don't actually have the processor in there. Now, that's what they used to do in the old days before they got smarter and then even smarter. So, And of course, then there is the complete standalone where you're writing code, simulating it, and running it on the PC itself, and you never have an RX63N. You're only running it in a simulation mode on the PC itself, which is pretty good for identifying general software that runs. But as you can imagine, it's going to be really hard to simulate button presses or I/O input or something else like that. All right, I have digressed, so let's return. I think I did all this. So with Hue, like any of our other integrated development environments, you're going to have a workspace of which you can have multiple projects open at one time. So you should be careful to understand that you can have multiple projects available and open. You need to make sure to close off the ones that you don't want to have included. And then within that project, multiple files. Some screenshots. I think you could read these notes and what's in the book as well as I can. And a lot of it is inherently obvious, but to keep in mind that you will have the ability to create a new workspace based on another one that has existed before. We are the YRDK RX63N, and in fact you can pick up tutorials, and the only thing I do recommend is that your workspace name and your project name should have no spaces in it. Something funny happens in other tools when you add spaces or when you have spaces in the names. So just don't put spaces in the names. Yes, sir?
Underscore is okay though, right?
Underscore is okay and is a good option, yes. This is just going through another step. You can create an empty application, and in fact, for this one coming up, we've instructed you to actually take an existing application, that being the demo program. It has a whole bunch of stuff in it and an entire operating system on it, which may be good for you, it may be bad for you, but it's what you're going to need to do. Unless you want to do this entire project on your own, from scratch, which you're welcome to do. And the tutorial will simply flash the LEDs on the board once it's been executed, so you could see. At the very least, I would at least examine the tools that are available and some of the available demo code, just to ensure, one, that your hardware is working correctly, because some of these demos will allow you to actually test out all of the LEDs, the accelerometer, the temperature sensor, the additional potentiometer, etc. You will have workspace window, editor window, and of course if you have multiple files, you will have multiple tabs down here to be able to work with it. You have the output window, which there is a way for you to actually replicate the console. In other words, if you want to do a printf, there you go. There's your printf location that will allow you to do some debugging. A lot of this stuff should be, you've used an ID already. It should be inherently obvious. I think I'm going to go through these really quick. Output window, editor window, toolbars. The most important aspects of this is to make sure that your current configuration is the correct one. You don't want to be simulating when you think you are downloading to a board. Simply, you can clean all projects, you can build an individual file, you can build all the files, and then you can actually download and execute as well. Here we go. Launch external debugger is another common one that is helpful. There are certain files that will be used quite a bit for our Hue system and all the code. These are files that are already included for you, and they allow you to, for example, use some of the common names that we're going to see in the hardware manual. So, as an example, this one will, I'm trying to find a good one. Macro sizes, I guess it's not in this list yet. Here we go. Define various input and output registers. That will actually identify that port 1 is this particular memory map location in your entire memory map for the processor. So if we were to look at the I/O defined, let's see if I could find one really quick. I used to put all this stuff out here, really. I did not put it out there. Well, I would have to dig in too many places to be able to find this for you, so I think I'll just go on. But it actually has the information for assigning the addresses, as well as identifying that if this is a bit, then it takes up these particular 8 bits to make the entire byte, and these 4 bytes to make up your long word, etc. You can find this is almost like a tutorial. We also have that available. As we said, or as I said earlier, when you are debugging, you can reset the CPU and actually run the particular program that you have loaded. You can step in other words, if there's a subroutine, it will step into it, go step by step. Step over, meaning that you don't even want to execute that, or you can step out of the particular code that you want to execute. And of course, all with a stop once you're done. Just a list of keyboard shortcuts. Some instructions on how to create a new file, some more tutorials, and that is all I wanted to cover on chapter number 4. Thank you very much.